So Swarm is on some level, just a peer-to-peer file storage and content distribution network. It is meant to be it was part of the original Ethereum project. So the Ethereum project had three parts: a blockchain, a storage and data network, and a communications protocol. The idea was that if we want to completely reinvent the way the web works and fix all the mistakes we made getting to where we are now, we need more than just a blockchain. The blockchain is great for coordinating little bits of consensus relevant data, like assigning a hash to a username. But if you want to use a dApp, you're going to need images and text and JavaScript and files and like a lot of data, and that can't go on the blockchain. So you need, if you want to truly go serverless, you need a different a network for that. So that was Swarm. It was meant to do that. And so Whisper was the name of the third plank, a communications protocol that was aimed at being maximally anonymous and secret. Whisper, while it was developed, never used much because you pay a very high performance penalty for the secrecy. It's there, it works, but most people don't have such a high need for secrecy that. So what Whisper was about was saying not just you can't read the content, that's easy, but also you don't know who's talking and to whom they're talking or any of the metadata. It was just all based on probabilistic routing of encrypted data. Anyway, Swarm, as it was building out its content distribution layer, realized that it could just as easily use that same network to route messages, so the whole messaging suite of the Web3 can also run natively in the Swarm network. But that's going a little too far. Let's just see what we have now. I have a Swarm node running on a server somewhere, and if you call that up, this is what it looks like. So we don't actually expect in the end people to interact with Swarm manually. The idea of an infrastructure layer is once it's running, nobody should know it's there. It should work just like the regular web. What we can do, for example, is if I type in something in the address bar like swarm.eth, I will get a website. And what actually happened? There's a whole number of steps that just happened. The name swarm.eth .eth is not a formal top-level domain. It is a smart contract sitting on the Ethereum blockchain. There, the name swarm.eth gets resolved to a content contract, which can get queried for Swarm content, which returns a Swarm content hash, which then, with this content hash, we go querying peers in the Swarm network to see who has data that matches this hash and render it, and there's our website. So there's a lot already going on. And of course, the nice thing here is we've got complete guarantee that this is the right content because the hash is it's integrity protected, this network. So you don't rely on the server to give you the authority that this is the correct content. The blockchain does that. A name to a hash. That little bit goes on the blockchain. All the rest of it can live in a different network. So that's how it looks like. Another thing I always like to highlight, I'm going to call up something called photoalbum.eth. So photoalbum, well, that was a typo. Photoalbum.eth. There we go. So this is an example dApp that's live. It's very basic. There's 3 photos in this album, and they're actually explanations for how this works. Maybe let me call up another one. I'm going to do a subdomain we have called example.photoalbum.eth, and it's just some pictures there in our personal photo album. And this, the reason I like calling this up, because why do I care about some random person's photo album? Because I want to highlight how this is a very, very different from the Web 2.0. The content and the format can be independent. So this photo album, while it looks to you at first like just a website, it is also an app that you can use for your own content and your own photos. So I can make any changes to this album as I want. I can say, for example, I don't want this photo here, it's kind of boring. I don't want that to be the first one. I want to move it down in the order, so I click an arrow here to move it down. And then, that didn't work. Moving down. Come on. Well, never when you're doing it live. Should be a delete. It was working earlier. Because I don't wonder why I'm getting these errors here. Oh boy. Okay, why does it give me incorrect swarm hash? This makes no sense. Well, that is why you don't do live demos. Let me try one more thing. I'm going to try to add a photo, seeing maybe that works. I don't have many photos. I just have this one I took just moments ago. If it doesn't work, I'll leave this aside. The idea here being that as soon as you make changes within this app, when it's working, then the hash on the address will change because you've changed the content. When you delete a photo, you can't actually delete it. Something's on the web, it stays on the web. But you create a new copy of the same app where that photo is missing. And then you can, one by one, you could delete all the photos that are in this album and upload your own and then save that hash under your name. And you've copied the exact app, the photo album app, with completely different content. So it's kind of more of a read-write into experience for this app. So that they do work differently from websites. That's the only takeaway I wanted to give you. You have a question?
Yes. You said that the URL, so to say, that comes from that smart contract that you make yourself.
Well, the smart contract is part of the Ethereum name system. So in the Ethereum name system is is a system where domain names can be bought and you can attach a payment address to it. So I could say pay aaron.eth. I don't have to give you an Ethereum address. Or I could type aaron.eth into this browser and it loads the associated Swarm content or IPFS content or other stuff. So it's just a very generic system for assigning data to names. And it also actually allows you to use other domains. Like if you have a domain name in the domain name system, you can add a text entry with an Ethereum address and then sign it with DNSSEC, then prove that signature to a smart contract and so on, and then import your name onto the blockchain that way. So it's a very flexible system.
It's very generic. It's not something specific for Swarm. It's something.
No, it's not specific for Swarm. Yeah, good point. I don't know why this didn't work, and I'm sorry that it didn't. ETH. Last try. Oh, there it worked. So I deleted the first slide of the 3, and then you see now it has this address, and that address is this photo album with only those 2 slides in it and nothing else. I'll upload the photo again here if it works. I'm encouraged by the fact that it worked before. So let's try this. Uploading photos, and there it is. There's you guys just moments ago, live on Swarm. Then I don't want this thing in there either. I will delete that. So I've not deleted it. I've created yet another version of the album where that photo is missing. And then you take this one out, and all we are left with is a photo album where this is a photo of you guys. So this is now, it's not a photo album website, it's a photo album app that anyone can use, interact with.
And this, you would need to connect this one to a new name in the...
Yeah, so you can either share that hash with your friends, or you save that under your own name on a smart contract, and then you'd have your own album with different content that way.
So do you have 4 albums now?
Oh yeah.
There's one of the 3?
There's all these different albums there. The thing is, the storage layer is maximally deduplicating. We're using the exact same data for all of them. The only thing that's different is like a little snippet of a JavaScript file which tells which content hashes to store. And those are duplicate, yes.
It's like in the photo software, like Aperture. You don't change the raw file, but you change the metadata on top of it.
Yeah, so the photo album itself, we're using the same JavaScript, obviously, the same everything. And then there's a little content JSON file which says what the Swarm hashes are of the photos to show. And so yes, we've got about 4 or 5 different versions of that little snippet flying around, and probably most of them will never be queried again.
I'm involved in copyright management for the music industry.
Yeah?
So that's perfect. So you have one original file, and it can be part of many albums.
Yes, and indeed there are people working with Swarm and music files to track not just which files are being played where, but who are the promoters and whose channels it's going through, so you can actually do the full value chain and automatically see who should get paid along. Right? Like, yeah, there's definitely a lot of interesting use cases. Now I'm going to show you one more example album that I saved under a name. I think it's test.theswarm.eth. Great, namely a bunch more slides. So these are slides I used a little while ago in Berlin. So this is I was asked to give a 30,000 feet overview of what Swarm is. And then I start saying, okay, what is it? Why would we need Swarm? Why are we even working on this? And it comes down to being the sovereignty of the digital space. We've given up sovereignty over our personal data, and people in the blockchain space, they love talking about, take back banking and finance and everything money, which is fine, but it's not really the interesting part. For me, the interesting part of this revolution is the sovereignty over the digital commons. You want to have a social network that's actually social. You want to be able to really own and control your content in a sort of very, very fundamental way. So Swarm, on a basic level, uses the same network as Ethereum right now, the same peer-to-peer connections, because it started off within the Ethereum network. And the nodes connect to each other. They form a routing topology within that network, and that's how we route data around. When data enters the Swarm, this is a key point. This is where Swarm differs architecturally from BitTorrent and IPFS and a lot of other networks. The data is split into chunks, and these chunks get spread out throughout the network. You don't have seeders like in BitTorrent or pinning like in IPFS. The data really gets spread out as evenly as possible. That is so that gives us a redundancy, and it also means that there's an ability to upload data to the Swarm. You can't upload to BitTorrent, you can't upload to IPFS, but you can upload to Swarm, and then you are no longer responsible for any of it.
So it's like forced net neutrality.
Well, it's content neutrality, right? You're simulating a global hard drive, so it's just you put data on there, it gets spread out, and the way it works that every bit of data tries to get moved towards those nodes whose address are closest to its own hash, and then that's where other nodes will later know to look for the data and request it.
Does Swarm also make copies of shards, pieces of the original, or
So everything will get cached on every node along the way,
okay,
and then there's a redundancy at the local level. The closest, it's not the closest node, but I think the 5 closest nodes who all try to keep a copy. But they're just doing this out of economic self-interest, because the way the incentives are set up is everyone's interested to store chunks that other people might then later request from them. So, but we'll get into that. That's whole swap side of things. So yes, all accounting and payments go between peers. There's no global accounting system because there can't be. It's a peer-to-peer network. And while data is being forwarded along Kademlia routes from one to the next, to the next, to the next, to the next, payments are only ever between peers. So when you connect to the Swarm network, you have a list of peers, and you do long-term data with these. So we can actually, a single chunk I could send you, and then you don't pay me, I don't care, I lost a chunk. But it's the discipline of repeated dealings, because you have long-term connections between the peers, and there's constantly data moving, constantly payments moving, and the rest is just rounding errors. So this is really the core of how the network, the economics and the routing works. That this is, and yes, and it's built for Ethereum. So we said we're doing Ethereum payments, but there's no reason it has to be Ethereum, because since you're only doing payments with your immediately connected peers, settle in whatever you like. That the network doesn't need to care, and it doesn't. And we're building it so that even from the very beginning, we can already use some other tokens. Okay. Those were my slides there. So just really high-level view.
Yeah, I have one question.
Yes, please.
Who stores the descriptor of how to reconstruct the file? Because it's easy to break it down.
So the file gets split into a bunch of chunks. These chunks all have hashes of their own. They're packed together into a new chunk, and that's just another chunk. So when you look on the blockchain, that swarm.eth has a content hash. Let's look it up. I'm gonna here. So bzz hash swarm.eth. So this is the content hash of swarm.eth. This content hash will refer to a single chunk. That single chunk is 4 kilobytes of data, which is 128 hashes concatenated. Each one of those refers to another chunk, more or less. I mean, there's redundancy and erasure coding all down this chunk tree, but pretty much that's how it works. So that chunks that are routing data and final leaf data, it's all completely symmetrical. So yeah, if I query that chunk, I should also get the website, just as I did by the name. Yes?
And the photos went really fast. How long does it take to put a movie back together? Say a gigabyte.
It really depends. That's all I can say. So I do have one film, I think, on demo. And it also, yeah, that works fast too, but that's because I loaded it earlier. So the question really is, how fast is it? Now, if you go on the web now, there's some sites that run slowly and some that run faster. The fastest thing you will likely experience is when you're illegally downloading a TV show about dragons. And that's because a lot of people have the data and then you get it from a lot of sources. So there's a lot of unused bandwidth. And that's what we're trying to tap into, right? From all this, the peer-to-peer and the end layer. So if there's content in Swarm that is popular, the way the Swarm routing works, it'll automatically be cached in many, many nodes, which is, I guess, similar to BitTorrent having many seeders, and then it goes super fast. Whereas if something's rare, it'll take longer. So I can't tell you. And also in this case, I loaded the content earlier, but I was testing. That means my node requested it from all the peers, and at that point my node had it cached, and it'll take a while before it starts deleting it again and having to re-request it from the place where it's stored. So
if you have a node and you make a script that it downloads that certain TV show from the Swarm network, then it will be ready for you the next evening, right?
sure, I mean, yes. But I mean, hopefully you don't need to download it from the Swarm. You can just play off the Swarm. It should be fast enough. And because of the way the tree works with all the hashes, you can read arbitrary segments of a file and still get the Merkle proof that's guaranteed that this really is that segment of that file. You've got proofs down to the 32-byte level that this is the correct piece of data. And that's architected in such a way that later on we can do proof of custody, proof of storage, and so on rather easily, which we haven't done yet and we're not even going to talk about. Maybe just one more little thing. I gave a talk here in Amsterdam, in Amsterdam, not here in Utrecht, about Swarm in 2016, and so it's been a while, and I found really nice slides back then where I talk about why we are building what we're building, and I think it's an excellent introduction to what Rinke will be talking about. So I'll just give a small segment of the talk I gave that time, then we make a brief history of what incentives are like on the internet. Right? So the incentive structure of, right, is this presentation mode? No, it isn't. How do I present the F11? Yeah. So the incentive structure of Web 1.0. So this is back in the 90s. So you have to set up your own web server, or you rent a web server, usually some gray box sitting in somebody's office or warehouse. Then you upload some content to it. You'd have an FTP client copy from your site to the other one. And then usually your content is unpopular because nobody cared about your stupid little 90s website. So that's fine, except you pay the running costs and you can say, hey, I have a homepage, and show people the URLs. Great. Now, if you're lucky or unlucky, we'll see when your content becomes popular. Great, good for you. All of a sudden, your bandwidth cost skyrockets and your server crashes and nobody can see your site. So those are the two options you pretty much had. Right, so definitely room for improvement there. But at least you owned your content. Right, at least you own your content. Whereas today, in the Web 2.0, we just upload our content to the so-called cloud. And we like to say there is no cloud, just other people's computers. So I like to say Swarm is going from cloud computing to crowd computing. But I don't know if I can do that joke when we go to Osaka. It's not right, huh? See, anyway, the cloud we have now. It's cheap, or even free. Free in quotes, because it isn't. It's scalable and it's reliable, but the service providers do own all the data, and all users are tracked and spied on, and the providers profit off of that data. Yeah, so and we have centralized control, so this leaves us open to censorship and surveillance, and both those things are dangerous and are being abused, daily. We see that in the news all the time. So when we talk about incentivization in peer-to-peer networks. Well, okay, let's start with BitTorrent, because everyone knows about BitTorrent, the biggest peer-to-peer network. The content is distributed amongst many peers, great. The distribution scales automatically in the sense that popular content is faster. We've got the data integrity you get the hash in the torrent file with magnet link, and that guarantees that the data you get is what that hash referred to. And there's no central point of failure, no servers. I mean, there's very, very well-funded entities that have been trying to take down BitTorrent for over a decade, and they haven't succeeded. So it's a remarkably resilient network. But there's downsides. So downloads start slowly. There's a very high latency. So it might work for a movie file, but not for a website, because at first it starts trickling, and only later is there this torrent. There's no incentive to provide content to the so-called seeding. So sometimes content disappears because nobody is running these nodes, and we depend on the altruism of a bunch of people to keep these networks running. And we can do better. So I'm not going to do the swarm incentive layer, because I think that's precisely where I tie into Rinke, because today, so the swarm incentive, we've been talking about this, as I said, for years, and we haven't actually done it because a lot of things needed to be, I'm done, thanks. Yep. A lot of things needed to be built, like just the storage, the data, the routing. It's remarkably complicated, because the failure modes are not within any one node. It's usually across a network of nodes, and we have to develop whole new testing suites for how to figure out how the emergent behavior of a bunch of nodes is. So it's not just unit testing. You have to sort of write a scenario where 50 nodes come up with different data and different addresses, a request comes in, how it's routed, and so on. Now that we feel that's getting more mature, we're finally able to tackle incentives. And the first bit of the incentive system is just, you request data from me, I send it to you, and after a while you pay me. Just that little segment. And hopefully today we will have the world's first swarm incentivized test network running with all of you guys. But I'll let Rinke talk a bit about the swarm accounting protocol.
Well, thanks, Aaron.
If you want the mic.
All right. Well, thank you, Aaron. I think I couldn't have wished for a better intro than this one. Aaron came in like this morning, and we were like super surprised that he was here at all. All right. So I'm going to talk about Swarm with SWAP enabled. So what is SWAP, right? SWAP stands for the Swarm Accounting Protocol, and within Swarm we have many of those acronyms, and they're all strange, but they all start with SW, which is Swarm. SWAP is a Swarm Accounting Protocol. And this is, by the way, where I've been working on for the last 3 months as a smart contract developer, and lately also a Golang developer. So ask me anything about it. Okay, so from the previous presentations, I think right now you get that chunks, they are spread throughout the network, and chunks, they are just these tiny pieces of data, 4,000 bytes if I'm correct, and they're retrievable upon the bonds. Like you demand the root hash, and then it kind of gets trickled down to all these like leaf nodes, which are the chunks, which is data, in which you assemble again, and then you have a website or video or whatever. And I see that my animations don't work, so I wanted to ask you any problems with this, but you see the answers already. Incentives are really crucial if you want to build such a network, because you need the incentives to build a robust, scalable, and a DDoS-resistant network. Because what if you don't have those incentives? Well, I can tell you that right now, everything which Aaron was loading was probably running on how many nodes? Maybe 30 nodes, which are maintained and run by Swarm. There's other nodes as well from people who just like Swarm and want to play with it, but there's nobody actually like running Swarm nodes because they want to run Swarm nodes.
Yeah,
it's all
say, like, in the world of internet storage, there's real big money involved. The fact that it's all hidden from us in the free services doesn't mean that there's real hardcore business in data centers. So if we're trying to decentralize all that, there has to be economically self-sustaining. So it's not just about, I want to make money on my Swarm node. No, I want data center owners to say, we're switching our data center over to Swarm.
Exactly.
So they need to be paid for their,
And I think the best example of this, which we all know, is probably Bitcoin and the proof of work consensus mechanism, right? Like, they've been trying to make DigitalOS for like a really long time, and it was only at the point that they actually built a system where people had incentives, that it was their own choice to join the network, and it was their own choice to actually continue mining Bitcoins and talk about it with friends, that it became huge and unstoppable. So we need this if we want this scalable, DDoS-resistant, robust network for digital content. And this is what we're doing right now. So within Swarm, the incentives layer has been part of the whole Swarm architecture from, I would say, day one. But what Aaron said, it's only that since recently that we started to build on this. And here you see some pictures. It was actually the start. This was in Hungary. This was in Madrid. In July, we really started to build on this, which is a collaboration between IOV Labs, a company I'm working on, and Voitech as well, and Swarm, and we work really close together on this. So how does swap work? Well, in the basic, it's really simple. It's basically nodes who are just in a network. They are nodes. They keep a track of the balances they have with all the peers. And a node doesn't have a connection with all the possible peers in the network. It's the logarithm of, no, it doesn't matter, but just a subset of all the peers which exist. They keep a balance. They keep track of how much do I owe you and how much do you owe me. And the balance can be both positive or negative, just depending on whether your peer is using up more resources or whether you are using up more resources. And you can just see it like this. If a balance tilts too much to one side, then I will pay the peer. And if the balance tilts too much to the other side, I'm expecting a payment from the other peer. And this depends really on the discipline of repeated dealings, what Aaron said, because in Swarm, like your peers, they're somewhat fixed. You're expected to deal with them, so it's like, yeah, that's how you keep the balances with your peers. So what do we price at the moment? Well, we basically price pay to download content. So if in Swarm, if you want to download, let's say, this presentation, you have to pay like a tiny bit of amount, and it's not a lot. It's all like micropayments, but you pay a bit for this, and at the same time you also get rewarded if somebody downloads a bit from you. What we are going to implement, and that's not yet, but it's on the roadmap. We want to have an anti-spam measure. It's for uploading, because right now you can just download or upload as much stuff as possible and flood the network with, I don't know, cat pictures or whatever you like to do, but there must be some kind of anti-spam measure. And also there must be an incentive for long-term storage, because all we've been talking about so far is about popular content. But what if I want to store, I don't know, a photo album, this example from Aaron, but it's a photo album of, I don't know, really long ago. I never look at it anymore, but when I want to look at it, I want it to be available. So this is a whole different game. So we made a nice GIF about, I'm Dutch, that's why I say GIF. We made a nice GIF, and here down you basically see, we call it the chunkometer. It's not like the official term, but that's how we like to call it. So you see it's basically the balance which you have towards one peer. And you see now it tilts towards one side. I'm downloading a bit more from the peer. Now the peer comes in, he starts downloading something from me, and then it hits the threshold, and we repayments, and then it goes back to 0 again. And this is how it happens. So if you and your peer just downloads approximately equal amount of content, then no payment ever has to happen. If there is a high variability of content downloading, or if one peer is maybe downloading too much and the other peer is just not, then we are expecting a payment. If it doesn't happen, no man overboard, then yeah, you just disconnect. That's the other threshold in red, called the disconnect threshold. These are not big amounts, because even this payment is an off-chain payment. It's not that we're doing an on-chain payment for every transaction here. Yeah, but that uses the blockchain.
Do you have a side channel or a state channel?
I'll come to that later. Yeah. So popular content. What I already said, Swarm is currently only usable for popular content. That's because of like the economics in the system. Because nodes are programmed to behave in an economically sound manner. So what is economically sound in this content? Well, they have limited storage capacity, and they can, of course, store any chunk they want, but they will be most profitable if they store the chunks which are accessed most often. Because if you are storing a chunk and your peer requests it from you and you have it, then you can give it and you can earn a bit of profit. But if you don't have it, then what you do then you ask another peer whom you expect to have it, and you'll be just only a route. So then you only pay and receive, but in the end you earn nothing. So popular content gets cached, and that's why popular content is very quick in Swarm, and you can download it quickly. Yeah, and what is that? Non-popular content needs a completely different incentive scheme, about which I'm not going to talk about today, but there's papers written about this as well. The checkbook, that's the kind of payment channel system we use. It's called the checkbook for a reason, because it works exactly like how a regular check works. So you can see this is a smart contract, which is on Ethereum, and you as a node, if you join the Swarm network, and you'll see it later in the incentives workshop, you're actually going to deploy your own checkbook contract. And with that, you can write checks.
Maybe the younger people here don't know what a check is anymore.
I mean, yeah, we know. Okay, I'll explain it anyways. This is the check. I'll come to that later. So you can write a check, and that means that you're signing a piece of data. You're signing a piece of data, which means to whom am I paying, how much am I paying, and a signature. Exactly. So that's everything. And with this piece of data, your peer can actually will get it from you via Swarm, and he can validate whether that's correct, and he will accept it as a payment, because he knows that later on, if I want, I can give it to the checkbook contract and actually be paid out in real Ether. Yeah, and here again the principle of repeated dealings is important, because what you could do as a node is you can overpromise on checks. So you have a checkbook with a sum, let's say 1 Ether, which is underlying this checkbook. And because it's off-chain payments, nobody can guarantee that I'm actually promising 100 nodes a payment of 1 Ether, because these nodes, they won't be able to talk to each other to validate whether they are the only ones who will getting this 1 Ether. It doesn't really matter. But that's a very important security dealing underlying the checkbook contracts, that you're repeatedly dealing with the same nodes, because
If you're a new peer,
Yeah.
I might cash your checks every hour, and when I see that working, I might just wait and accumulate them over a day. But the thing is, it's my choice how much security I want. The longer I wait,
Yeah.
the lower my gas costs for cashing in the check. But during the time when I'm not cashing in, it's not really guaranteed, because maybe you've written more checks than your deposit actually covers. But so if it's flexible in that way. So I can cash every check that you send immediately. If I don't trust you, I'll pay the gas costs. But after a while, I might relax that, because
Exactly.
I see that you're always good for it.
yeah.
Can I validate the discrepancy between the amount of checks provided versus what's deposited?
Yeah, sure. The smart contract is programmed in such a way that if one of the peers who are actually beneficiaries of this checkbook figures out that there is, like, he writes to the checkbook, hey, I want to cash out 1 Ether, but the checkbook says I don't have 1 Ether, then it will fire an event, and all the peers will know this. And Swarm at the moment not, but that's one of the issues which is underlying, that all the peers, they're actually listening for this event happening on the blockchain. So when this happens, they will probably disconnect, or like there will be some measure taken.
Is it now blacklisted or something?
Yeah, they might probably something like, we're not clear about this yet, but there is an event which says a check bounced, and all the peers there are going to listen for that event, and when something like this happens, I don't know, the peer will be punished, or he will probably be disconnected, or something like this, but something bad will happen. Okay, so what is a check? I already explained. A check signs what is the contract address, so to which contract can I present this check, what is the beneficiary, and this is an Ethereum address, what amount am I talking about, and the signature. And this amount is cumulative, so I'm not going to write a new check for every payment I'm doing. Now the first check will be maybe 1 ETH, next one will state 2, the other one will state 50, then they'll state 100, and it's like a cumulative amount. Yeah?
There's a node.
There's exactly.
It's like your first check, second check, third check. So if I get 3 checks from you, I only have to send number 3 to the checkbook.
Exactly. Yeah.
It covers 1 and 2 as well.
Yeah. Okay. I think this is my presentation on Swap as well. So, if there's are there any questions? Yeah.
The
Yeah.
But the beneficiary is an Ethereum address.
Yeah.
So then it's on-chain payment, right? If you pay when the amount is in Ether or not?
Yeah.
Yeah, then it's on-chain payment or not?
No, the only exactly. So you send you send this piece of data. You send off-chain. I can send it to you by post. It doesn't matter, but we'll send it via the Swarm protocol, and it will be your choice to present this one on the blockchain and actually get the Ether, or keep it and wait for another check to appear and save a bit on gas
Okay,
cost.
but you can verify the payment is made on-chain.
Yeah, you as a beneficiary will be able to verify. You look up this contract address, and you're going to verify whether this contract address actually has a deposit of more than 100 Ether, and then it is your choice to present it on-chain and make it an on-chain transaction, or keep it and save on gas cost. And yeah. More questions? Yeah.
You're talking about incentivization, but I want to ask a question about GDPR. Is it possible now, or is it another?
When an inalienable right means an immutable blockchain. So sorry, yeah.
No, it's about strong concept in the whole. When you have a hash which refers to chunks,
Mm-hmm.
is it GDPR proof? Is it? Can you still link information to a certain person?
No.
Let's say an X-ray.
No, I mean, this is hard. You can't delete stuff off the internet. We can't either. Like if I'm running a site and I control my ENS name, which refers to a bunch of data, I could remove reference to that data from my manifest and mark it as deleted, and it's still there. It's the same thing Facebook does when you delete stuff. There's mark it as deleted in their database, so we can do the same thing, no problem.
Yeah, you mean as right we forgotten.
Oh yeah, sorry. What were you asking specifically?
It's just in general. Can you link the chunks to a specific address? Or to
No, so a chunk is so small, so it's such a small piece of data that only the chunk itself won't tell you anything.
No,
It's because it's 4,000 bytes, and 4,000 bytes is generally too little to get some kind of like.
Generally also encrypted bytes.
Yeah.
And so the way this photo album app I showed you, it can't actually track its users because I was running it off my node. If you launch Swarm, you'll be running it off your node. There is no point at which data can be collected about who's seeing it or who's downloading it. And every time your peers ask you for data in Swarm, you have no idea whether they want the data or they're just conduits for a request that originated further away. So
Besides, you don't have any idea that the data you're delivering is part of
yeah, you
the
don't
whole.
know, you don't know
yeah.
what it's part of, and it could be part of many things. Indeed, so the plausible deniability is built in on a very low level. Things like tricks we were playing with is things like you have a file made out of 2 chunks, just as an example. Like you can say, well, no, sorry. There's a nice example. Our cryptographer on the team did this nice thing where he said, okay, I'm going to have 2 files, which if I XOR them together, I get an image of Mickey Mouse. And if I take the same pieces and XOR them with something else, it gives a picture of Tux, which is the Penguin Linux open source, no copyright. And so you've got 3 bits of data. If I XOR these 2 together, it's copyright violation. If I XOR these 2 together, it's just an open source image. And no piece is part of any file as much as it's part of any other file. And because any data that's already there could be used by anyone as a mask. So there's no tracking. You don't know who's getting data. You don't know what the data is.
and the more chunks you have, the safer it is.
And the bigger the swarm is, the more anonymous.
Of course. Because the root has the descriptor of all the rest.
The root hash is a hash of a chunk. You don't know that it's a root hash. You just know it's hash of a chunk.
You can, as a regulator, you could identify this hash resolves to a copyrighted piece.
Correct, but the constituent chunks could also be something else.
I agree. But
Yeah, so I mean, like in the end
top level
result,
chunk
what
would
you
be-
really need is the hashes, and those are the ones that would be on the blockchain. It's like the Pirate Bay just stores content hashes in its magnet links. It would be a similar thing here. But at least on the data level, if you're running a swarm node, you should be protected because not just do you have plausible deniability, there's like very hard cryptographic proof that you don't know what the data is, and having a bit of data doesn't tell you which data sets it can be part of. So it really is. So think of it not as someone hosting data. This whole network is meant to be like a hard drive, and the hard drive cannot have a censorship module to make sure that you cannot store illegal content on it. That's a layer above, and it would have to be here too.
Yeah.
Interestingly, if there is a source that you trust with saying data that shouldn't exist, that should be deleted, I could voluntarily, as a swarm node, listen into your hash feeds and start deleting that content as I come across it. Nobody can stop me doing that. If enough people in the network do that, then the content will be not retrievable. It might still be stored somewhere, but there's a kind of herd immunity. You know, there's all kinds of things we could talk about how you might implement censorship, but it's definitely a layer above, and there's a social component that on the fundamental low level, it's meant to be censorship resistant because otherwise it's not reliable.
So it is possible to remove content, but given that peers will agree to
Well,
cooperate.
You have your node, you can
Yeah.
delete whatever content you want from it.
But the content is distributed across not only my node, but also
Correct.
other nodes. So I would need to delete from my
You
node
can't do
and
that.
other.
Well, you can't do that. There's
I
no.
cannot.
It's like you control your hardware. You can delete it. You can't delete it off other people's nodes. But so, for example, if what Rinke said about popular content with the current way swap works, if there's content which just maybe everyone uses the MyCrypto app on Swarm, and you look up mycrypto.eth and download the greatest, newest hash. When they do an update of their software, they upload the new version to Swarm, they update the hash on the blockchain. Now everyone's loading the new content. The old content is still there, but as nobody's requesting it, it moves lower and lower and lower in every node's priority queue, and eventually those chunks that are no longer requested just gets garbage collected, and then the whole Swarm forgets. So there is a deletion just by, if nobody cares about them anymore, they get deleted. That's different from going in and saying you should get rid of this content. And there is no mechanism for that.
Okay. Any more questions? Yeah.
How does it work with duplicate data? Say I have a picture, I uploaded it again. The hash of maybe some parts will be the same. Does it?
Then it's the same chunk.
So it won't store it again.
Nope. It's maximally deduplicating. So if 1,000 people upload the same image, it'll all get routed to the same local cluster, and they will store one copy each.
Cool.
Which also, when you update your website, and it's like a 6 gigabyte website, you update a little thing, only that little bit
Will be
chunk.
changed.
And the other really lovely thing, what I think is super exciting, is a lot of today's Web 2.0 companies got so huge by locking in a network, the network effect of the walled garden. Like, I could start running my own Facebook clone, and maybe the software is much nicer. It's not going to be as valuable if I don't have all the people. However, in a Swarm deployed dApp, I could simply fork, not just, like, you can fork WordPress, the code, but you can't fork WordPress.org, the website these days. With Swarm, you can fork the live network. I can, first of all, just take the hash of the social network and store it under my own name. And then I can make small tweaks to the interface and store that under my own name. And people can interact from different apps with the whole same network, because you no longer can lock in everyone on your app. So you really have to compete on quality. So this being able to, what open source did for code, where you can fork the code, we might be able to do for live running instances of web apps. And I think that's a very exciting dynamic in the future. But that's getting a little ahead of where we are today.